Welcome to the world of discrete electronics. Step into a realm where precision and creativity converge, where circuits come alive through individual components working in harmony. Discrete electronics is the art and science of crafting systems, using standalone elements like resistors, capacitors, diodes, inductors, and transistors. Let us build strain meter for general use. This strain meter shows whether the strain is compressive, reducing the length, or tensile, increasing the length, when an object such as a strut on a crane changes its shape. The strain is sensed by a strain gauge that is glued to the object being tested. The change in resistance of the strain gauge produces a change in the reading of the meter. This circuit is basically a strain gauge amplifier circuit, designed to measure small changes in resistance, caused by mechanical strain. Strain gauge, SG1. This is the sensor that converts mechanical strain into a change in resistance. IC1, 7805. A voltage regulator that provides a stable 5V supply to the rest of the circuit. IC2, 7660. An instrumentation amplifier that amplifies the small voltage signal generated by the strain gauge. IC3, 741. An op-amp configured as a non-inverting amplifier to further amplify the signal. R1, R2, R3, R4, resistors used in the instrumentation amplifier circuit to set the gain. VR1, VR2, potentiometers for fine and coarse gain adjustment. R5, R6, R7, resistors used in the non-inverting amplifier circuit to set the gain. S1, on-off switch. C1, C2, C3, C4, capacitors for filtering instability. Strain gauge signal. When the strain gauge is subjected to mechanical stress, its resistance changes slightly. This change in resistance results in a small voltage difference across the strain gauge. Instrumentation amplifier. The instrumentation amplifier, IC2, is a high-precision differential amplifier specifically designed to amplify small signals from strain gauges. It amplifies the voltage difference across the strain gauge while rejecting common mode noise. The gain of the instrumentation amplifier can be adjusted using the resistors R1, R2, R3, and R4. Non-inverting amplifier. The output of the instrumentation amplifier is further amplified by the non-inverting amplifier stage using IC3. The gain of this stage can be adjusted using resistors R5, R6, and R7, as well as the potentiometer VR2. Fine and coarse gain adjustment. Potentiometers VR1 and VR2 provide fine and coarse adjustments to the overall gain of the circuit, allowing for precise calibration and sensitivity control. Output. The amplified signal is then fed to a multimeter for measurement or further processing. Stay tuned and keep learning. Subscribe to our YouTube channel www.codingscientist.com.